Dear students, myself Dr. Anup Kumar. I am going to teach you production technology subject, and the topic is the casting. Production technology deals with the different type of manufacturing processes. To understand this production technology subject, you must have the knowledge of the metals. You have read in your BTech first year the electronic structure of the metals. The electronic structure of the metals is going to help you to understand this subject. At the same time, you will be able to develop these manufacturing processes. These manufacturing processes are being done with the different way, different technology. So how to develop this different technology and how to perform, this subject has got objective. So what is the course objective of the production technology? The main objective of this course is to emphasize the importance of manufacturing science and to expose the student to a variety of manufacturing processes. Let us see here. The objective of the course is to emphasize the importance of manufacturing science. Science is involved here. See, you have read in the physics science. In that one, I told you the electronic structure of the metal. By knowing the electronic structure of the metal, you can come to know the property of the metal, and accordingly you can modify the manufacturing process. So you should have a lot of knowledge on the manufacturing processes. So here I will be teaching you the main objective of this. I will expose you to you people in variety of manufacturing process like casting process, farming process, different farming processes. Next is to teach the process level dependence of manufacturing system through tolerance. See here, through tolerance. Whenever you do any manufacturing process, you must know the what is the here tolerance. Dependence of manufacturing process through tolerance. What is tolerance here? Tolerance means suppose you are making patterns, suppose you are making the casting. In the casting process, the shrinkage allowances are to be given. So how much shrinkage allowances you need to give, that you have to understand. So how much tolerance before any production, how much tolerance is required while making the tool, you have to, while making the pattern, you have to understand. That has to come in the beginning. Next is to emphasize the basic manufacturing processes and tool used. Now here the tool is very much important here. Tool is very much important here because once you use the tool, suppose you are doing a metal forming process. For doing the metal forming process, you need to design the die. So you need to design your punch. So the dimensions of the die, suppose die radius you have taken. That die radius is very important. Suppose the die radius is less, the metal instead of getting deformed into a shape, it will get fractured. Understood? So you have to concentrate here on the designing. Thus tool is very important factor. So I'll be emphasizing you, I'll be teaching you. The main objective is to know the tools before manufacturing any product. What are the tools are used in this manufacturing process? You should know them. Next is to teach the thermal and mechanical aspects such as force, strain, stress, strain, and temperature of the most common processes. See here, very important objective of this subject is I will make you to understand thermal and mechanical aspect. Thermal aspect, suppose I am going to manufacture a product. That product is to be manufactured at room temperature. When I am manufacturing at the room temperature, a lot of stresses are getting developed. See, what are they getting developed? A lot of stresses are getting developed, and at that time, because of more stresses, the product which you obtained is not a correct project. You did not obtain a sound product. Thus, now to, and at the same time you have expended more mechanical work on it. You have expended more mechanical energy on it. Because of the more mechanical work, more mechanical energy, more cost is happened. So the optimization is required here. Thus, if same work which is to be done at room temperature, if you done at the bit 100 degree or 200 or 300 degree, now what will happen? Its force required is less. It will be easily deformed to a product, and the properties of the product which is made, that will have a better properties. Now another thing you see here, suppose I have done the work with that work I have done with the titanium alloy, which can be deformed at 800 degree temperature better. Now you see here, what is the, I have deformed a titanium alloy to make a good product and at 800 degree. Suppose I do same work at room temperature, it will not deform, it will fracture. Now what happened at that temperature? At that temperature, what will happen? At that temperature, its internal structure gets changed. At room temperature, suppose I have taken alpha beta titanium alloy. So at room temperature, there was alpha particles, there were beta particles. But we know that this titanium alloy at 900 degree temperature is its beta transverse temperature. After 900, 950, if it is a beta transverse temperature, then at near about before 900, 800 itself, all alpha starts getting transferred into beta structure. Now, alpha was the XCP structure, it got transferred to BCC structure. BCC structure is more deformable. Thus, the product which I will obtain at BCC structure will be better formed, and the better formability I achieved from the titanium alloy at 800 degree temperature. Thus, thermal and mechanical aspect has to be considered, and at the same time, when I did the deformation at higher degree temperature, the forces required were less stresses developed, and material got less strained, and our product we got ready, a sound product came. Further course objective is continued. The course is, this production technology course is designed to teach the conventional manufacturing processes. What are the conventional manufacturing processes? Like casting, metal forming, and welding processes. You will be here taught in this subject, and you will learn. But see, conventional process does not mean it will remain conventional. I will teach you these processes. In that one, I will add the modern science and technology, what is happening at present all over world. So these conventional process will work like a modern process. Thus, you will get a product which is the defect-free product and valuable in the world market, compatible product you will get. Next is the production technology course outcome. After reading this subject, what the benefit you are going, means what the knowledge you will be, what knowledge you will have. So what is the course outcome? Let us say, identify the effect of process variables to manufacture defect-free product. Just now I last slide also discussed, manufacture the, you will get the, what you will get here? You see here, products, course outcome. What is course outcome? Course outcome, main outcome, by having this knowledge you will get the defect-free product. This is our course outcome. You will understand the welding process, gating system design. So one by one I will explain you. So defect-free product, that is the main important here. See process variable. What is meaning of process variable? Suppose I am doing any process for manufacturing. Suppose I am doing the farming operation. During farming operation, what I saw? During farming operation, what are my variables? Just now I discussed in last slide, temperature is the variable. Process variable. For farming process, temperature was the variable. Force was the variable. And though even the velocity of the punch was the variable. So you will understand in which process what are the variables. That is the outcome. And this variable you will understand. With this knowledge of the variables, you will get benefit. You will optimize these variables and you will go get a defect-free product. Next is understand the welding process. You will be able to understand welding processes. Different welding processes will be taught here. You will understand the welding processes. And by understanding such a, suppose you do a welding with arc welding, suppose you do a welding laser welding, suppose you do a welding with some gas welding, then you test that weld piece, which one has got more strength, which has got better microstructure, which product is better. This knowledge you will understand after going this subject. Design of gating system in metal casting processes. You will be able to design the gating system, because if the metal is poured inside a casting, a liquid metal, and that has to flow. And what happens, a liquid metal is a dense. If the gating system is not properly designed, the metal velocity will be slowed down and it may not reach at the last corner of the casting. So gating system design you will understand with this. Understand the idea for selecting material for patterns. Just now I discussed patterns. When you select these patterns has got shrinkage allowances. So what material will shrink how much? That much allowances you have to give in the pattern. So with the help of the knowledge of the materials and knowledge of the pattern, you will select the pattern material, so that a proper tolerance will be maintained while getting the casting product. Next is the type and allowances of the patterns. Different type of patterns are used in the casting. So all different type of patterns you will understand, and you will also understand how much allowances are to be given for these patterns, and what type of pattern is suitable for what type of the processes. Next is the develop process map for the metal forming processing using plasticity principle. What you will do? You will develop the process maps. What are the process maps here? Develop the process maps for the metal forming process. Metal forming process is done. There are workability we will understand. Formability we will understand. What is formability? Formability is a ability of the metal to be deformed into proper shape without getting it failed. Formability is the ability of the metal to be deformed in the proper shape without any fracture or rupture. So you can draw the formulaic diagrams, and in the formulaic diagram for a particular material, you can see the area in the map. Above this curve, material will fail. Below this curve, material will not fail. It is safe to deform. So this knowledge you will gain from this subject of studying this production technology. Now next comes casting learning objective. Learning objective. The first topic in the metal for this, in the your production technology subject, unit 1 is the casting. What is the learning objective of this unit 1, casting unit? First is to inculcate the thermal and metallurgical aspect during solidification of metal and alloys. What is the during solidification of metal and alloys? This knowledge of solidification is very much important, because of the knowledge of the to inculcate the thermal and metallurgical aspect during the solidification of the metal and alloys. To inculcate the thermal and metallurgical aspect. See here, thermal and metallurgical aspect. Please concentrate thermal and metallurgical aspect. Both has got very much relation. Two things, thermal, metallurgy. Thermal means if a material is thermal first. If a material is heated to a particular temperature, whatever the grain structures are changing in this one. Now a grain structure changes. If you get the on solidification coarse grain, materials mechanical property will not be good. So now second thing is metallurgical aspect. As the temperature increases and cooling rate differs, metallurgical aspects changes. See, understand here, student concentrate please here. Thermal and metallurgical aspect, both has got the relation. Whenever suppose in the casting, what will you do? You will be heating the metal or pouring. So metal will go to melting temperature. Again, you will pour it inside the mold. After pouring inside the mold, you will give time for the solidification. When you give time for solidification, that time, if cooling rate is high, coarse grain will form. If cooling rate is slow, a granular, rather you can say a fine grain structure you will get. So thus metal has got relation thermal with the metallurgy. So both things are to be please remember. So solidification of metal is very very important. So the objective I will teach you. For solidification you have a knowledge. When you become a real engineer, that time you will use the solidification knowledge. Now to impart the knowledge about the methods of casting with the detailed design of gating and riser system needed for the casting. I will impart you the knowledge. Please understand here what knowledge? Method of casting with detailed design of gating. Whenever you make any mold, in that one gating system is there. Whatever gating system knowledge is required, you will have a metal, molten metal. Molten metal, nothing. Metal is melted and it is in the melting position. And molten metal you are pouring inside the casting. Once you pour inside the casting molten metal, what will happen? It has to move. It has got certain velocity. It has to move from one place to other place. So with this velocity, it is moving. Now it is moving with this velocity, and this is a very dense metal. You know, iron, if you melt it, how much dense it is? After melting, it is dense. So it will move very slow. So gate, now area of the gate we have to consider. The diameter of the gate we have to consider. If the diameter of the gate successive are made in a smaller diameter, the velocity of the flowing liquid will increase. Because there is a relation between the velocity and the diameter of that gate. Understood here? So next, that's why riser system needed for the casting. Now riser system, at the last all material will go, at the last we put the riser, and so that the material will go and get collected in the riser. Riser nothing, it is a reservoir. Now this knowledge of the, I will teach you the knowledge of riser. Whatever riser is there, material is there. And on solidification, whenever the material will get solidified, its level will decrease, and the metal from the hot metal from the riser will come, it will complete its level, so that your product will have a proper tolerance, it will have a proper dimensional accuracy. Understood, please? So this is knowledge I will teach you while teaching the casting subject. Next is to impart knowledge about defects in cast objects and requirement for achieving sound casting. See, I am here imparting the knowledge for the defects. What happens whenever you make the casting surface finish may not be good, other defect may come. So you should have some knowledge of what type of casting defects and try to avoid these casting defects when you become a real engineer. So this knowledge also I will give you, so that you will get the sound casting when you become real engineer. Next is to impart knowledge about pattern materials. I need to give you the pattern materials knowledge. So while selecting the pattern material, you will select as per the process. So what process, what material you are selecting, what process, what material you are selecting, and that material, with that material, how much shrinkage allowances you have to give. So now I will impart also the knowledge of pattern material. Which material is better, whether wood is better, aluminum is better, POP, plaster of Paris is better. So different patterns of different materials can be used here. Now the casting introduction. Now you understood your course objective, you understood your course outcome, you understood your learning objective of this first unit, casting. By knowing this learning objective, I will go casting. Some introduction of the casting I will show you here. Our nation India produced the casting around 300 BC. Means this technology in our country has been used long back. One more thing, a good example, our country is having, if you go to Delhi, Qutub Minar, one there is an iron pillar. that is 7.2 meter high. It has got a big diameter and it was made that time pure malleable iron. It is not rusting till today when it was constructed. And remember this, what a best technology they are having. With that technology, so far this pillar has been made and sustaining with the good quality sound casting. This is also a example of the sound casting of the, in our nation old age itself it was made. Again, another thing you are knowing, China started in 1500 its casting. Indus Valley civilization is famous all over world for casting. That time also they were making weapons, tools, utensils, and maximum material they were using copper and bronze. So, but nowadays we are using the different mechanical, different materials for the different mechanical parts production purpose. Casting. What is casting? Please understand all of you. Very important topic. Students, concentrate please. Casting is a manufacturing process. Casting is a manufacturing process. What happens in the casting? Please remember, casting, manufacturing process in which a liquid material. What is here? This here liquid material. Liquid material is usually poured into mold. From where we get the liquid material? Liquid material we get generally from the furnace, and we bring this liquid material in the ladle and we'll pour in the mold. Why? In the mold there are the cavities. In the mold there are the cavities. What type of cavities are there in the mold? That cavities are exactly as the required our object. So you see here, and in that cavity metal we pour, and then we allow it for solidifying for some time. This time is not 4-5 minutes. This time is near about hours, 2 hours, 5 years, 10 years, 12 hours also. And so that, see, already I discussed with you, the solidification is important. If it's solidified with proper cooling rate, the grain structure which formed, that will give the better mechanical property, a sound casting you will get. And this solidified part is taken out from the mold, and this is known as the casting. Please again understand here, what is a casting? Casting is a manufacturing process in which a metal, molten metal is poured. Molten metal, from where it is to be poured? Metal is to be melted inside the furnace. You see this figure, please. This figure shows the, if you melt the iron, you see here, exactly same color you will get. I've seen the furnaces while melting, and after melting you will get exactly same color. Though even those who are very excellent engineers, long back by color they can recognize what will be its now temperatures. So this color you got, it is showing that it is a molten metal, and this molten metal is poured inside the mold. What is this? This is the mold. Through pouring basin, it is poured inside. Where it is going? It is going inside the cavity, and then cavity get filled. After getting cavity filled, this mold is allowed to solidify for some period. After solidifying this mold, for some period, what we'll do? After solidifying, we'll take out this object, and this object is called casting. So important thing are here, please understand. Molten metal, pour inside first. Second one, let cavity get filled. Third one, you must give the time for solidification. After solidification, you take out the casting. Now you see here, by this figure it is very much clear. What is this here I am showing you here? You see in this figure is showing the mold. This figure is showing the mold. See, this is the mold. I am drawing this line, this is the mold. Mold has got two parts, lower and upper. So bottom one, this is bottom one called drag, top one is the cope. And in this one, what is this kept? Pattern. How to make the mold? See, mold is taken in that one, this is pattern is kept. And after keeping this pattern, Surrounding we'll put this sand. We put this sand. And we'll do ramming of the sand. By doing ramming of the sand and we put the pattern, afterwards we will remove this pattern. When we remove this pattern, after removing this pattern, what we'll get? We'll get the cavity. Automatically this cavity will be there. What are the cavity you see here? These are the cavity. These are the cavity. Clear here? So this cavity you will get. Now your mold is ready with the cavity. How to prepare the mold? Take the mold in this one. Put the pattern. After putting the pattern, ram the sand surrounding the pattern. After putting sand surrounding the pattern, remove the pattern, this cavity is formed. Then close this mold from top, mold cope, and then fill the molten metal in this one, allow to solidify. After solidification, open the mold, take out the product. That product is your casting. Though even with this casting process, we can make very complex shapes, which is not possible to make with any other processes. Thus, this casting process we can make very small and very heavy, up to 200 to 400 tons with the help of this casting process. From this figure, it is much more clear. You can see here. This is your pattern. This pattern generally we keep inside the mold. Put the sand and ram it. After ramming sand, we take out this pattern. After taking out the pattern, cavity is formed. Close the mold and pour the molten metal. Allow it to solidify. After solidifying, you will get the casting. See, this is the casting. You will get this casting. After getting this casting, this is the product. This casting, what product you are getting here, bottom, this may not be having good surface finish. This is the casting you got. So this may not have some good proper finish. So for that secondary operations are carried out. Now with this, we can understand now with this discussion, what are the steps involved in the casting. This is very important for JNTU point of view. Sometimes it is asked in the examination. Casting is also called foundry. So what are the steps involved in the casting? What are the main steps? Please remember, first is the preparation of the mold. Second is the melting and pouring the liquefied metal. Third is the solidification. Fourth one is the defects and inspection. So what I told, just please, first step is the preparation of the mold. How will you prepare the mold? Take the mold, keep the pattern, around the pattern, ram the sand, take out the pattern, cavity will be formed, close the mold from top, cope, you got the mold. Now melting and pouring of the liquid metal. Melting and pouring, first you have to melt the liquid metal in a furnace. From there you have to bring a ladle. Ladle is nothing, it is a container in which a very hot metal can be brought. So in the ladle you will bring the hot molten metal, you will pour in this one. Liquefied metal means molten metal after melting. So then next is solidification, and then allow it to cool for some time, give more time, proper cooling rate as per the knowledge, and let it come to the room temperature. Then open the mold, take out your casting. Now this casting, whatever you obtain, may not have good surface finish. So, or it may have some defects also. So on the surface you can see visually what are the defects, if any found. Try to overcome in the next process, so that no rejection and production cost becomes cheaper. Optimize production cost, because your product has to be compatible in the world market. not in our country level or not in our state level or in the local market. So that's why we must be make our product defect free. Then you can go for the inspection, like if internal voids are there, internal any problem are there, you can go for the X-ray and other chemical non-destructive testings are there. So this testing you have to do, and if you found that any defects, try to overcome so that your least rejection will take place and you will get the better product, sound casting you will get. Thank you. Please ask the doubts if you are having. After your after satisfying you, I will give the assignment. Please write the assignment. What is casting process and what are steps involved in the casting process? Please write down what is casting process and what are the steps involved in the casting process. Thank you.